6.6.
All right.
Got it.
There we go. So what do you got going for us, Vinay?
All right, so I am doing an extension of my previous project, which was taking EEG data, directly sonifying it, but now I'm doing it in real
You
time.
have the thing on.
I got the thing. Yep.
I didn't know you were putting it on. Sorry about that.
No, perfect. So the weirdest part about this was just like figuring out how to read the data, because when it gets sent over UDP, it's just straight up binary. So I had to separate all the signals, convert it from binary into floating point, and then do all the fun stuff with it. And so there's no documentation about how to convert, like what order the binary stuff is in and how to do anything. So I did all up in customer support, but we got there. And so on the left side are all the EEG channels. On the right side, there's 3 channels of accelerometer and gyroscope that I have access to in this too. And what basically all I'm doing right now is taking the EEG directly, turning it from like just floating point values into a signal, and then pitch shifting that up to an audible range, and then bandpass filtering it in the range that we can hear and sounds nice. And then
So we're hearing the actual EEG sound itself. I'm actually mapping that on.
Right, I'm not doing any mapping right now. Cool. Yeah, just the EEG sound. The only other things that I have put in right now are using the accelerometer to control how much pitch shifting is happening and the volume as well. So you can kind of move your head around and make it sound a little different. So fingers crossed, let's see.
The sound gets quieter.
So I'm just using one camera right now, but I want to do the whole like spatial thing, do all the different microphones and make it sound like all over the place. That would be with all the different sort of sound speakers. Yeah, I saw that once. I would love it. Yeah, and then if anyone has any other better ideas on how to use the accelerometer and gyroscope data besides just like volume and pitch shifting for what frequencies, all ears.
One thing I do that's a little bit of a trick, you might think about another sort of data thing you can get very easily from that information is just the derivative. And that shows you how fast you're doing that.
Yeah.
That versus that,
Yeah, I'm kind of getting that with the gyroscope. For some reason, this isn't working as well, but I had it set up to whenever I would make like rapid movements, you would hear like the maraca or like some kind of something get hit to just like kind of be like. So if you like start to bob your head to the beat, then like you can like hear. Not only will the EEG get louder and softer in time with that, it'll also like you'll hear a note on every down.
So like Federico's headbanging.
Yeah, exactly. Yeah.
Cool.
That's the project.
That's pretty amazing, I gotta say. Is there anything you can do with the richer data that you get from that we can't get from our headphones?
So
our headsets?
Yeah, the other thing that I wanted to do that we kind of talked about before is like filtering it out into the different frequency bands. So like getting alpha and delta, theta, beta, and then seeing like, okay, if you close your eyes, the alpha power should go up. So then how can we make it like sound more relaxing in that state? But then it's like further away from direct sonification and more towards something that's more imposed upon the sounds themselves. But still like combining those things, I think, is the most interesting thing. So like one factor that is like truly your brain sounds, and another factor that's like interpreting it in a way. So pretty cool. Yeah.
Okay, question: how much does that headset run you back?
This one was 1,000.
That was not bad, actually.
Yeah.
Yeah, we might be able to score one.
And it's, I mean, yeah, just like super simple. Turn it on, press a button, and then we have data's live.
That's not the emotive one.
No, it's called a unicorn.
What? That's a new one.
From G-Tech. It's this Austrian company that we get all of our research stuff from too.
Wow.
But they're actually hosting a brain-computer interface like spring school right now. So if you're interested in doing that, it's just like a free sort of thing for learning about BCIs.
Yeah, it's interesting. A lot of these interfaces I've noticed are bringing in a lot more stuff, like, that's not just brainwaves, but also has the gyroscopic data.
Exactly.
We have a prototype, VR goggle from Hewlett Packard that goes 4 hours.
Really?
That, it does the VR stuff, but it also does eye tracking and it does biometric data.
Oh.
The idea is that you can design games that are really scary.
Yeah. That'll like something will pop out at you exactly where you're looking.
Yeah,
You
yeah,
know where
yeah,
you're
yeah,
looking.
yeah.
Yeah.
Or it's noticing your heart rate.
Oh.
Let's do something that.
You were too calm. Time to change that.
All right, cool. Very,
Yeah.
very cool.
Any other questions? Yeah.
Hope you do it some more because it's really cool.
Yeah.
Like how long did that take?
I've been like, I mean, it took, honestly, the most time was just like interpreting the data that I was getting from this, which took like a few days. But then the rest of it was like figuring out the scales, figuring out the pitch shifting. A lot of it is like doing the same methods that I was doing before, but just in real time instead. So the project before definitely took a lot longer, and this time was like, okay, just putting together these pieces that I know how to use. But yeah, definitely would like to do more of it.
How do you choose the bandwidth that you're using? Because you said you're separating the signal into some sort of bandwidth. Is
Yeah.
that a machine learning kind of thing, or is it just from here to here?
No, so right now it's like just from here to here. I do want to use, I think it would be really cool to like feed in all of the EEG samples into like Flucoma or something and use that as the corpus that is constantly building, and then figure out a way to like put the samples together in time. That's also something that I thought of during that lecture. But right now I'm just saying pitch shift it up by between 50 and 100 times, depending on how you're tilting your head. And then filter it between, I think right now I have a resonant filter between, centered at 250 hertz. I was trying to use filter design too, but it like started working and then stopped working, and I had a lot of issues with it. But yeah, like learning more about filtering in Maxim SP is definitely going to be useful.
Yeah, they've got some good filters about that. There's always RTC.
Yeah, exactly.
Yeah, that's because the brainwave signals themselves are all like 10 hertz.
Exactly. Like this thing samples at 250 hertz, so you can use up to 125. But like the actual brain waves that you get, that isn't just noise, will be like no more than 50 hertz.
Really, I didn't think they went that high.
Yeah,
Yeah.
even then it's like kind of noisy.
Yeah.
And some people will say you can get 60, 70, 80, but I don't buy it.
Cool. Great, good job. Okay, so next on the list from the interns is Sivan.
I was still trying to because I know there will be a problem of connection because the Hodon IST app. When I was using my Wi-Fi at home, it works fine, but using Columbia University.
Yeah, I have the same issue. You know what you can do is to connect it with a USB cable. That's what I always have to do here. It never works in this house. I don't know what is going on with the Wi-Fi here.
Okay.
But
Sivan, do you want me to come back to you? a little bit?
Yeah.
Okay.
if you just use the cable to make a USB connection, then we'll be fine. But
I'll try.
yeah, I've experienced this problem several times. In fact, when I was showing it here, it was also not working, so I needed to use the USB cable.
Tim, you're next. What do you
All
got?
right. So, share screen.
And make sure you're sharing sound too.
What is this? Install a Zoom audio device.
Yeah, now it's installing the Zoom audio device.
Oh.
Oh, yeah,
Is it? Am I sharing?
Yeah.
Yeah.
Great.
All right. So,
Great. You did do this.
what do I get rid of? Yeah. So what I did was, I call it short stories and sound, and I worked with an API from Google Cloud that's called sentiment analysis. And what this does is basically this. Sentiment analysis is described as positive, neutral, or negative out of some text or sentence, or I think it even works with a simple word. It's positive is if the sentiment is good, neutral, if it's neutral and negative. Those positive, neutral, and negative are actual values like minus, 0, and positive. So what I did first was try with a simple function, and what I did was just input 3 sentences. I'm happy, I'm so sad, and whatever is fine, I don't care.
It's like passive aggressive.
I think you just described everybody's trajectory through the semester.
And this is the output I have. So then it makes sense. This is positive, this is negative. And after I got the output, I figured that this is kind of passive aggressive, but it's subjectively neutral according to. And then my next step was to input a whole book. So I tried with Alice in Wonderland. I found on the internet the whole book from chapter 1 all the way to the end.
That would be interesting to see what the result was.
And this is the result I got. So my first idea is that this is very chaotic. I don't even know what's going on here. There are so many points. And the first idea was to get rid of some points, but I thought that wouldn't be a good idea because since this function or signal is not continuous, I just would be losing data. So my next idea was to use the idea that low frequencies are the ones that carry the signal around, and high frequencies are just noise. Exactly. So I applied this kind of filter. It's called a Butterworth filter because I didn't want to get rid completely of the high frequencies. And this was the result I got. The orange one is the filter signal, the blue one is the original, and the green one is 0. And my first observation here was that the poor Alice is most of the time in a negative environment here. There are only like 3 points where it's not so bad around her. So out of curiosity, I try to figure out where those points were. And these are the actual sentences in the story. I'm not very familiar with the story, but I'm pretty sure this is not Alice that's happy. I think this is a rabbit, someone singing, and the soup, I think it's the queen who's having the soup.
Wow.
And
Quick question, were you doing it one sentence at a time? Was each data point one sentence?
yeah, each point in data in time is a sentence. Exactly. Yeah. Sorry, I forgot to mention that. Thanks for the question. Then the next step was to generate sound out of this data. So my first assumption here was that trying to map positive sentiments with order, with sound order, and negative one with chaos, that is, in this case, just randomness. And with order sound, I just assume that is what we know about music theory. So for that, I thought that it would be nice to use Wekinator. And my outputs in Wekinator would be a chord progression and a chord. With chord progression, what I mean is this, what we see in this image. Like 1, 5, 6, 4, it's like a nice chord progression. So the output would be one of these numbers. For example, this last 4.
Yeah.
And the actual chord, because each one of these numbers could have a lot of possible values in each chord. And then the input is the sentiment score that we have in our data. And also, I wanted to use the past chord progression. That is, for example, if we are at this point in time, to Wekinator to be able to get a 4 out of it, then it should be able also to see the last 3 chords, that is 1, 5, 6. So my idea is that Wekinator, after seeing these past 3 values, would be able to output a 4. I think it makes sense. So this is the layout of the model. So I have my data in Python that goes to Wekinator. To Wekinator, there's a loop because of the past values it needs, and then the sound is created in max. And this is perhaps one of the coolest things I could figure out. Each line of this is a training sample, with the first half of it being the input and the last the output. So the first one are ordered ones out of music theory. I think it is right. I'm not sure though. And then the second half or the other part is just randomness. A lot of randomness. And then just in a for loop, and I think this is pretty cool, I was able to communicate with Wakinator in a simple function. And I'm just saying, Wakinator, start recording. Then I set the output of Wakinator, I send an input, I stop recording, and I tell it to train. So it's basically pushing these buttons, but very fast in code. So I think it's pretty cool. And then this is what I got. Oh, should I do anything?
You're gonna play that for Max NSP?
Yes,
Go to your,
the batch is really very simple. So it's,
If you need to, yeah, go there and then set that to the Zoom. The output device.
it's thinking.
Right.
Now you can turn on the ESP.
Just do this. Oh, and I'm also communicating with Max through code. And now I call that the conductor because the conductor is telling this port to turn on and start everything. So here we go.
So let me ask a few questions, because I'm not quite sure exactly what we're hearing. When it was playing the long tones up above, was that when it was happy then? Or?
No. So the happiness value should be the ordered chords and the ordered chord progression. But I'm not sure how to interpret the audio output because it's like very messy.
I see. Okay. Yeah. That's what I was. I guess I was hearing the right thing. Okay.
Yeah. So
Yeah.
what I think happened is that Wakinator does some kind of regression, and perhaps what fit better here would be a classification because a regression just tries to fit the points everywhere in the field.
Yeah.
But I think music theory is not linear. It doesn't really have an order.
Yeah.
So it might not make sense.
Yeah, I think, that's, at least in Reckoner was trying to expand it to fill the whole range too. And that's why I think you had so much in the high end too. Where I think that might have been more instructive to hear that down in the middle range, just a little bit more, but then your bottom would drop out. You know? So I think you're right. If you did it as a classification sort of approach, and you had it specifically because you only have kind of 3 states that you're looking at, and if you classify them directly into those 3 states, then I think you probably hear really well. But it's amazing you've got the thing working and everything, you know? I mean, when you described your project, I thought, oh, okay. But that's really impressive. The other thing is, you know, that I didn't say anything during the describing the project, maybe I just hinted a little bit. When you start dealing with emotion and music, it's really tricky because people have very different takes on what's this, that, or the other. You know, I think it was a good starting point to say, you know, something that's going to be a chord progression versus something that's going to be chaotic. You can differentiate those very well.
Yeah, that was just a decision and I made. It's completely subjective.
Yeah, exactly. But it's your subjectivity, so
Yeah.
it's correct. Cool, that was amazing. Good grief.
In general, I'm not sure about the result I got, the actual audio result, but I'm happy with what I got. Like
Yeah. No. And like I said, you got the skeleton there that, you know, doing the whole thing. That's pretty amazing. And also learning how to use the weaponator like that. That's gonna be more.
Yeah.
It's great.
Are there any questions?
Yeah.
Do you try other like text to see like something that had more positive things? Like would it come out sounding a little nicer?
Yeah, not yet.
Okay.
I'll try it right now.
Yeah. Actually, think about what would be a positive text. I mean, everything I can do is kind of
Some children's story maybe?
Yeah, but even those, I mean, have you ever read any Grimm's Fairy?
Yeah.
They're so gruesome.
Like, you know, send them off in the woods.
Yeah. Even the ugly duckling gets bullied. Like
Oh my God. And you guys, this is just like child abuse. You know, there's a famous Danish children's author named Hans Christian Andersen. Have you read any of his stories? They're insane. There's this one we got from my kids. It was called The Fir Tree. It was about like getting a Christmas tree, okay? So they bring the Christmas tree and they chop it down, you know, and keep the Christmas tree for a while. And then they get tired of it and they chop it up and throw it out in back. That's the end.
wait, what?
Those ones are dark.
Oh, they're really awful. And what's his famous one, The Steadfast Tin Soldier? You know, where he's in love with his ballerina, but the ballerina likes this other doll, and the other doll doesn't like the ballerina and hides off. The ballerina falls down the fire. The Steadfast Tin Soldier falls down the fire too, and they help. That's the end.
I read this one.
Yes.
Yes,
It's a famous
it
story.
marked me so much when I was a kid.
Okay, good job. Yeah, that's great.
Would you be able to use music as the data instead of text? Because it would be interesting to simplify, like on my Spotify Wrapped, it said that my like emotions were happy and spooky. And that was really weird to me because I didn't think the music I listened to was happy. It could be the lyrics, or you could use the chords.
Yeah,
Like you would need a
would
program
be
to
very
pull out the chords.
What is it? How do you define the sentence?
Oh, and music? You know,
To
probably
measure
to
if it's happy, you know, sad.
Oh, it's just.
I think Spotify's API actually has like
Yeah.
emotion ratings for all the songs. So you could use like sentiment for
Right,
that.
exactly. There's a lot of analysis tools for doing that, actually. Yeah.
And in the
Everything is in Python in my final Jupyter, no?
Sivan, are you ready?
Yeah,
Or
I'm
you
ready.
Okay, cool.
I just don't know if I have to join with audio if I share screen because it means the how I speak is gonna like output all this.
Okay, let's try it and see if it.
Okay.
I think Eliana's also got some interactive stuff. I'm kind of watching it on my
So I think there's arrows.
Try turn your volume down. That might work.
Oh, okay. So
So it's, you're having a feedback with yourself, it's not a network, it's really, so I think it's about the sound sharing sound. That's the,
Um, so like, I just choose my input and output.
yeah.
Actually don't know why.
It's interesting that it feedback although, maybe it's in your max. Well, what are you using for the sound right now? I think that's the feedback.
No, I don't think so. I don't have the mic. I don't have mic.
Open?
Is it because anyone didn't mute?
It sounded to me as if it
Laptop is
was
so old,
only
the battery is like this.
somewhat.
Right, because I had this actually turned, I had this volume turned completely down.
Yeah,
Oh, actually, I
this is like 8 years old.
Okay, so my project's name is Sonic Zone because I think it's Sonic and it's kind of have a notion of Zen. So, yep. I'll start with how to get the data I want. So I'll start with sharing my. I don't know if you guys still remember the Holozone. Oh, sorry, the Hololist that Nicholas was sharing to us last time. So it was like basically collecting data from your Apple Watch, your iPhone, your AirPods Pro, and the weather, which is from internet. So these are the data that is collected. I'm wearing my AirPods right now, so that is why there are change in the data. And here's everything you can use. And in the beginning, my idea is to sonify breathing. So it was kind of the biggest problem for me is that when you're doing meditation, everything is still, even though there's like small changes in those data, but it was like hard to I don't know, like putting the environment into the sound. So I was trying to build a neural network based on those data, but I failed. But I succeeding another way. So I'll show you all the process.
I'm not in the audio.
Yeah.
I think it's fine now. I changed the output of my.
I think we're good.
Were you getting something?
No, we couldn't figure out where it's coming from.
Okay, so there are several data that I shows. I choose the heartbeat as the cornerstone of my music, and I choose the head movement as my the body part of this music, and I choose several environmental data as the still part of the music. So the heartbeat is mapped to the tempo of the whole song. Because every sound is from me, so you can change the tempo of the whole part of it. And the movement part is from my AirPods, which is the altitude from XYZ axis and the rotation on XYZ axis. And the environment part is the elevation of sound and moon. And the average, it's not average. It's just the humidity, the wind speed, the wind direction, and the temperature. So basically, I just choose this data that makes sense to me when you're in the scenario meditation. Here is my mapping. So I have two buses, which is A and B, and each buses have 8 channels. As you can see, like in bus A, channel 1, there's heartbeat from my Apple Watch heart rate. Right now it's pretty high. Sorry, and it's growing. It's 117. Right now, I think it will change. Yeah, it definitely will.
I'm sorry to do this to you.
Oh, no, which one? What is it?
I'm just a little bit nervous.
Your AirPods measure your heart rate?
I know it's my Apple Watch. So AirPods here is basically doing my hand movement, like if I move my hand. So here's the Mac part, and then we'll go to Macs to see how I build everything. So basically right now you can see this is the, sorry, there's a delay. Okay, so this is the trained neural network. It's already trained, but I'll train it from scratch right away. As you can see, if I move my head, there will be some movement. Because this is matched to, I don't know if, I mean, anyone go to the glaucoma workshop would know the multi-layer perception example. So I just borrowed that and just meld that into my project. So here is how everything works. There is like buses from A to H. As I said, I just put in data to buses A and B. And so the data was routed from channel 1 to channel all the way to channel 8. And this is the actually this part, the first part is the original sample from hollowness. I was using this as an input of my data to get every data from my AirPods, my phone, my Apple Watch, and then I just put those data into actually the scaled one because there was some process before I putting them into this one. So this is the sorry, I just gonna zoom up. So this is showing the here we have 6 dimensions because I was putting in the altitude and rotation of my AirPods. You can see pretty obviously like this blue one is measuring this direction. And so there is like 6 numbers from 0 to scaled from 0 to 1.
So it's even picking up your talking now.
Oh yeah, because like when I talk,
You're moving your
yeah. So sorry. We can train it from scratch right now. I'll just clear everything. So here is a simple multi-layer perception from the Fumo code example. First of all, this is the, sorry, I don't think, I'm sure it's
Both under the choose the zoom. Where it says output device. Zoom out your device. See it down there?
sorry, I'm just moving.
There you go. Making sound now.
So you're hearing this now because there are 10 factors causing this sound because everything in this slider is basically just 10 values and it's putting into this synthesizer. It's chaotic synthesizer. So there's 10 channels of this. This is the output of our neural network. The input is shown just now with the data of my AirPods. The output is a chaotic synthesizer. So here we are going to build in some examples of it, which is so I'm just gonna a random example. Actually, this is different from gesture or anything because it's not a still movement. For the input data, it's not I just stay in this way or that way. I tilt my head this way. You have to move it. It cuts the movement, the change in the movement.
Right.
So-
So it gets a steady state.
Yeah.
Yeah.
So this is like I just do it. Sorry, I should secure it. So I can- Here, after we view the samples, we can train the data into this multi-layer perception regression. We can just doing the regression part from the input 6 numbers to the output 10 numbers into the. So here is the MLC, the arrow. As I train more epochs of it, the arrows will go down. Ideally to 0, but we don't really have to make it out like over to that much. So after training, here's the this is a play mode that is really the weights you just trained. Yeah, so that was before I put everything into Ableton. Now I just put the 10 output from my neural network into same structure as how Hollowness is doing with the Ableton link. So here is my this is exactly, oh sorry, I have to read this. I have to restart this.
You have to set the output for every time you go to Zoom device too.
Oh yeah.
You have to set-
So my idea is that I want to make this meditative. So I'm using ambient sounds all the way. First of all, I just mapped as I said, I just mapped the car bit, which is in bus A and channel 1 into the tempo here. Actually, sorry, because I restarted Ableton, I have to redo every mapping. So I have to set a minimum value and the max value of this mapping from my heartbeat to the sound tempo, because I want to keep it something between 50 to 60, which is slow enough to not disturb you when you're mad. And I think we can just start to do this. So I also like bring my MIDI here, so which is also because I choose this, because this is when you touch this, it starts to make MIDI sound. So this is like, you don't have to really play it, right? But the sudden movement in your hand is gonna make a sound. That is, I think that is aligned to my notion of when you're And so here you can also see the input of my AirPods is doing here, which is changing the reverb, the gain, the delay, and also this is the temperature. This sound I was setting for temperature, and this is, I think it's changing the reverb level. This is also like everything from the moon, the sound, and the wind. It's changing the pitch, the amplitude, the bass, which because I set a major harmonic here. So yeah, everything is mapped this way. I can actually show you. This is actually interesting because I have to move my head. Like before I started to do this, I was thinking about doing meditation because when you're breathing. I actually checked my data. Like when I was breathing, there is changes in the head movement, but it's just not enough for my. I was trying to magnify that by my neural network, but I didn't train it that way, so I failed in this part. So like I have to move it real hard to make some sound, and then I realized it's not for meditation. It's for like the exercise you do after you sit for a long time, which is really good. And which just make you relax in this music and make you move your neck a bit.
Okay.
So yeah, that was most part about it. So these are the I record them before I came here because I think it would be a demonstration. So that's it. That's my hope
So the performance stuff works pretty well for you.
Yeah, yeah. The
The harmonic
workshop,
stuff,
I'm very grateful that I take.
Hey guys, shall we move along? Hey, Eliana, you're next on the list here. Ready?
Well, I don't have anything
Sarah,
for you
I
to
think here Ben have a question.
Oh, Ben,
Yeah.
you have a question?
Can you hear me?
Yeah.
I just was wondering what you were training the neural network on.
Or head movement?
Yeah, using my data from the hand movement from the data of AirPods.
You know what? I know why he doesn't know. See, you can't see. She has her iPhone.
Oh, I didn't open my video.
Yeah, exactly, that's why.
You can see she has an iPhone that's actually picking up gyro data from her earpods.
Right, but what's the label that you're training the network to?
Synthesizer parameters.
She's using a package that these guys showed us called Flip-On, and basically it can take a whole vector of values, and she's basically I think she's just vectorizing the values that are coming from the gyro, and that's what she's training out. So it recognizes this movement as opposed to this movement. Well, you can't see it, but yeah. Okay, so she can move her head one way, she trains it to recognize that and produce a certain output. If she moves her head another way, she trains that and it produces a certain output. And that's what she's using.
But all the stuff that is being mapped in live, are there aspects of that can be built into the neural network?
Well, the neural network is basically, it's a data reduction technique of sorts. And the neural network is the thing that's controlling live. The neural network is connected to, the output of the neural network is what's determining what's happening in Ableton Live.
Yeah, no, okay, I get that. I just don't. I think it's hard to. I don't understand what the neural network is doing.
The reason why I choose to use neural network is because I don't want to map my data directly into the reverb the delay because it doesn't mean anything. I want to like make some of my movements go towards some kind of sound before I really do it. So like I train the machine to know what kind of sound I'm trying to make when I do this, when I do that. I can also like make a bunch of math equations to do that, but it was just like too tedious.
Right.
I mean, that was also
Okay,
the
so
question.
there-
Yeah. So like
That was my
I
question.
asked,
Yeah. I guess I can't see what you're doing to train it. Okay. Thank you. Yeah, that's cool.
Cool.
thanks.
Eliana, what do you got?
Yeah, well, I'm gonna send you the finished product and I would love if you guys just tell me what you think once it's done. But I have this big plan for it and I'm working on it. It's just been like a learning curve for me.
It's fine.
But I'm getting there.
Yeah.
So my idea and my plan is to use two data sets. One from the Black Artist database, which is a website of like Black artists on music lineups. And I want to take data from probably 2019 to 2022 of instances of bookings, like percentage of the lineup, et cetera, time that people performed. I thought it would be interesting to feed that into the left channel. I'm gonna use like this patch called the Forbidden Planet patch. Yeah, Gregory told me about that.
Oh, good. Yeah, I'm
It's
glad you
like
got in touch with him.
very
He
old.
just, he knows
He
his
was so
stuff.
helpful. So yeah, there's this old patch called the Forbidden Planet patch. And it basically, yeah,
It
like
was
the
actually a demo
movie.
patch for Segment 7.
Yeah, so it lets you draw the shape of an FFT filter for frequencies. You draw it and you can apply it to any audio input. So I would have the left and right channel, and I'm gonna put one data set in the left and one in the right. So the second data set, maybe you guys tell me what you think. I wanna do Black artists 2019 to 2022. And then for the other Black artists like early 80s in New York, both of them would be New York. Or I could make the right channel artists in Berlin, because the reason I'm making a techno track out of the data, because techno was created by Black artists in the 70s and 80s. And they were inspired by Kraftwerk, which is the German group. And they were in Berlin, I guess. And now Dusseldorf. They were in Germany. Well, I'll take Berlin because I'm going there this summer. I'm obsessed.
It's all German.
That's all I'm saying. Yeah. So like, some people consider Germany the birthplace of techno. Some people say it's Detroit, and really it's like a combination of both. But honestly, the people who first made techno were Black artists, and now Berlin is known as the capital of techno. So I want to like create a song that like shows the like how many Black artists are performing in Berlin now versus here. And I would take like time played, like I was thinking I would just map the like louder parts of the data set, like when there's more artists playing, I would map that to a filter, probably a high pass filter. But originally I was thinking that I would map it to like a really heavy bass for the kick drum. But I thought that was too obvious. And I think it's more interesting to use a high pass filter because it's like taken so much for people to be on lineups. People don't get booked even when they're more talented. Yeah, do you guys think I should do New York now versus like the hip hop era? Or should I do New York versus Berlin?
So which kind of, so the database, which kind of music scenes does the database look at?
I would have to find it for Berlin because this is only for America.
In that
Yeah.
case, I'd say do the New York one.
And I don't have data for the 80s either, but I haven't looked closely.
Yeah. You should be able to get it.
Yeah.
I would say the New York thing, I think maybe sounds a bit more attractive because you're dealing with like versus like, you know. Where Berlin is one more degree removed and it might not be as connected as it might otherwise be. Even though we
Yeah,
know it is.
true.
I mean, it's right now, it's still very controversial. I don't know if you've read this in the New York Times about a week and a half ago. Did you see this article about the Frankfurt, the new Frankfurt Museum of, Frankfurt Museum opened up this whole new thing, okay? Didn't mention a single black artist in the entire exhibition.
That is not okay.
No, it's not okay, but then they also noticed that there's some other bizarre things. Apparently, the board of trustees had set it all up, there's like no females on it. It wasn't
Yeah,
a good
I
thing.
might, if I can find it, I wanna use gender as another
Yeah,
thing and maybe map that to a specific drum or a synth.
right. How many female techno artists?
There's a lot that they don't play.
No. Yeah. No, I think the New York thing makes more sense to me right now, but when you go over to Berlin, that could be the second piece,
Yeah.
You can expand it that
Yeah,
way,
I
once you
really
got the
wanna
technique down,
work on this.
Yeah, I know
also.
you've been working like a dog on this too, because, you've been really doing stuff, so don't worry about it. I'm very anxious to hear what you do.
Yeah, I wanna present the song and then if people wanna know what it was about, I'll tell them.
Yeah, and you have to remember, Kraftwerk was popular when I was your age.
Did you like that?
Oh, listen to it all the time. That song, Autobahn, went to #2 on the US charts,
Wow.
which is weird. Yeah, first of all, the song was 25 minutes long, They had a radio version that was only like 5 minutes long, Yeah, they're hundreds of guys. There was a studio in Düsseldorf.
I know, I had my rehearsal space there as a teenager.
Really?
Yeah,
A tiny
just
studio?
next door to Kraftwerk. But,
Oh my gosh.
I always only heard some lonely organ playing, and I was always saying, man, you can want to hear it rehearse, but I only heard this lonely organ for years. And I'm like, "Man, there's nothing going on here. And it seems they're done rehearsing.
Okay, now we better move on. Cool, Eliana.
Thanks.
And I really thank you for sticking with the class
Mhm.
because, it's
I'm not done.
good. That's great.
I have a question. Is it time series? Like the data you're dealing with, is it based on time?
Yeah.
Oh, okay.
And also there's some sets for like geographic location
Oh,
and hopefully there's one for location in the city too.
Cool. That'd be good. Totally.
If I have to make a data set myself, it would be cool to like make it with people's hometown too. Have that be another component.
Yeah. Cool. Okay, Ioana,
Oh, hi.
what do you got?
Yes, so let me share everything. But before, oh, actually, I don't really know how to do this. So share sound, right? Oh my God, wait, hear me.
And you
Do I
gotta
still
mute
hear myself?
yourself. Yeah,
Oh,
okay.
now I'm good. Okay, so as I mentioned during the, plan.
Right, this is the
meeting-
cancer data stuff.
Yes,
Yeah.
cancer data, as you can see here, CDC. So I really liked, I think it was one of the first lectures, maybe 1 or 2, maybe 3, when you showed us some data with violence towards women and the increase in guns.
Oh, right.
Being
When you're
bought-
looking at data sets,
yes,
yeah.
And that really, got stuck in my brain. I
Huh.
thought it was such a nice song showing some really terrible data. So I wanted to do something similar in a way, not with that type of data, but with cancer data. So it's been a long process and I found all my data on CDC and I have different data sets. So my first thing that I tried, also this is my first time ever, this is my first time ever doing anything close to music composition. So it was quite a process. I emailed Nicola maybe like 20 times on a Tuesday. I'm like, why isn't this working? It was just a column instead of a semicolon in a for function that I didn't even end up using. I deleted the for function. So it was a mess. But, so for this little patch that we have here,
Okay, now make sure that you're
options,
sending out to the,
audio, no, bad.
Okay, yeah,
that's
yeah.
right.
It was
Zoom
good.
out. There we go, cool.
Now what do I do? Oh, how do I get rid of this?
Just,
Upper left-hand
oh, it's
corner,
covered by
and then-
this,
yeah,
so
there
drag
we go.
that out of the way.
Yeah, but you
Did
need
that
to,
work? No.
You're gonna drag this out of
press
the
the
way.
How do I
sign
drag this?
below, as
Oh.
well as not-
Click X.
I had no clue.
She'll start.
Thank you, okay.
Yeah, yeah.
So what this data has in it is it's each state in the US with cancer data, like new cancer data over the last 20 years. And I just wanted to see, I processed the data and then I added this little RTC mix and I wanted to see what we get. Oh, we get nothing? Why do we get nothing?
Maybe turn up the sound on the computer with the bar.
Turn what way?
The here on the top right, is your bar, is it up for the sound?
Yes, it's all the way up.
Check your computer output.
Maybe you didn't click share sound when you started sharing your screen?
I think I did. Let me try that again. No, I am sharing. What is this? I am sharing sound.
Go to your settings.
How do I do that?
First,
I'm sorry, I'm not using Mac usually, so I have no clue what's happening. Okay.
Maybe go to output up there.
But I think that's correct.
That's all correct, yeah.
Do we hear it?
Or another.
That's what we have. It goes on for 16 minutes. That's way too much. So I decided I'm not gonna do that anymore.
You are a
So
very minimal composer.
that was so long. And I thought, 20 years, 50 states, it cannot be that bad. No, it was very bad. And then it went, because I had this little loop over here, it went on from the beginning again, so it never ended. And after that, I was thinking, okay, let's just look at the last 20 years for all cancer, last 5 years instead of the 20 years, for all the new cancer data that we have. I also pre-processed the data myself because I didn't really like how the CDC did it. And I wanted to see something else. So then we have this little guy. But guess what? It sounds exactly the same. Kind of boring, not really doing anything. So this is why I changed my approach. And here we have a bunch of little patches. And what I wanted to do is I ended up, so I wanted to compare the new cancer data with the deaths in the US over, quite some time. I think it was 20 years for the whole US, not for the states anymore. So it's just a loop that repeats itself. And I also wanted to add in a little wink of hope. So this is why I added this little sound, which is, I think I got this patch from one of the lectures that we did with the wind.
That's the wind, that's
Yes.
the island wind.
Yes.
Yeah.
So I really like that, but I still use the input from this variable. Get that, and now if we play all of this. So I just worked a lot on, all the durations for everything, for what kind of, instruments I want to show. I did this clarinet apparently and the saxophone. I don't do music usually, so I had to try a lot to get something.
Well, even if you did music, you have to try a lot.
But yeah, I think this one is kind of growing on me.
Yeah, no, that's nice.
And the final little patch that I have, I was thinking, okay, for the other one, like the third patch here. Oh, where is it? Yeah, so we have the little hope here. We have the new cases, we have the deaths. And I thought that was a little bit, too sad because it kind of emphasizes the deaths, right? It's like. So I was thinking, okay, let's just do something nicer. And I just looked at the CDC data for the colorectal cancer because there are screenings out there. And I know it's a type of pretty aggressive cancer because people don't really do screenings. So screenings are important. I've also worked with some colorectal cancer models myself. So it's something quite personal. And I wanted to look at, the screenings that are being done per state, which are organized alphabetically with the new cancers found. And we can kind of see through this. I also kept this little wind because I liked it there. And we can see how the pitch kind of goes down. Also for everything, like all the data, it only affects the pitch. The amplitude is kind of all over the place. Let's look here. Yeah, so it's just like this little frequency that I just shifted up a little bit for everything. So if we listen to this one.
Yeah, it's interesting in the netherworld between, dealing with real data and then musical necessity, because you wanted it to change, but the data wasn't changing. And it's when you hear it like that, it's pretty stark, So you want to go into the, we'll change the data. I like your approach of adding in some nice sound in the background.
Yeah, because it was so sad otherwise.
Yeah.
But this guy like drunk. Anyways.
Yeah. One of the things, I do like the way that you have like several different data sets going sort of simultaneously too, because that's actually a good way to compare stuff.
I feel like this one isn't too representative for the data, but I still think you can hear the pitch going a little bit lower.
Yeah. Well, and that's the other thing is, this is like I said, because we're a music class primarily, so you can do that because it sounds like so no, that's really good.
Thank you.
Anybody have any questions for you? Cool. We'll march right along here. Guys, every year this happens to me.
I'm pretty impressed to see how much it grew since Tuesday, since we were emailing.
Yes, I was so desperate then. I'm like, nothing happens.
I just, I get to this sort of final thing, and because we don't really do a lot of present stuff in class because I just tend to just lecture and throw stuff out there. I have no idea what's going to happen, and these things happen. They're just marvelous, wonderful stuff. So now, Ray, let's see some of your wonderful stuff.
I'll share my screen.
Yeah.
And share sound too, right?
Get you down for some music visualization.
Yeah, I was, so basically that's what I did. I guess I just wanted to sort of see if I can create some kind of like audio visualizer that can react to music. So my goal, so basically like there are two parts. So this part is like, basically, I was looking at a lot of tutorials online too. So this part is really just like learning how to create an audio visualization. So what it does is it just creates this matrix of just like really cool, fun, colorful little pixels. And then, oh wait, let me move this zoom thing out of the way. So you can sort of change the number of pixels in the matrix and the dimensions of each, or not pixels, but like, little sections of the matrix. There'll be like a lot, or maybe it'll be more vertical, just fun, just like fun little visualizations. And then this sort of just changes like the noise. So I'm using jitter to do these visualizations.
That's amazing because we didn't cover jitter at all.
Yeah, I was like, I don't really know how to make visualizations. And then I looked online. I was like, oh, jitter is something that a lot of people seem to use. So
actually, now that you've used jitter, you can see why I chose not to use it.
Yeah. I think it was really just like, okay, I'll see. I was just like really experimenting. But then there are cool things. So I just learned how you can like sort of unpack the different like channels, and you can add some kind of offset. So I think if you drag this around, or do not, oh wait, never mind. Maybe I have to. I think there's, I think it's showing, just doesn't show that well in these. I'll try to change it. Yeah, so you can see how it's kind of like overlapping a little bit.
Yeah.
I don't know if you can see it at actually.
Yeah.
Never mind, a bit.
Yeah, I can see a little bit. Yeah, look along
Yeah.
the left side as a matter of fact, yeah.
Yeah, I think you might have to change it. Oh, yeah, so I think you have to change it. Anyways,
Yeah.
so I was just experimenting with that. And then the other part was basically how to sort of create, like load in some audio and then maybe kind of have this visualizer react to that audio in some way. So what this is doing is I open like just a random music file and then I basically trying to filter out just the low frequencies. So I added in a low res filter. And then the goal was to maybe as much as possible have this visualizer react to audio, the like bass notes and maybe like the bass
Right.
drum.
Yeah.
Yeah, so that's basically what this is doing. It's kind of clipping the audio so that only certain basically only certain input signal ranges will basically trigger a bang, and then I just connected that over here, which is overall what's happening. So I'll just play it and then
Check your outputs.
oh yes, I think I changed it ahead of time. Yeah, okay, sweet. Awesome. All right, so let's see if this works. Oh no, is it not working? Oh, there we go. So it's kind of changing according to like the bass notes. But yeah, I think there's like a little bit of noise in there, but like yeah, you can see kind of so basically it's flattening everything, but sort of just these individuals are being taught shown in this video. But anyways, I was just playing around with that's what it was. So it was just fun.
It's actually working really well.
Yeah, so you can just change it as you're playing it. So it's just for fun.
What is the audio we're hearing processed? The high pass filter or like the original?
This is the original song. No, the audio itself is unchanged. I'm just
in there?
extracting. Yeah, extracting. Lower frequencies. Yeah. So yeah, I guess that's kind of
You decide the colors and does it mean something?
they're randomly generated. Yeah, that's basically it.
Boy, I really love it.
Yeah.
It's not picking up every single thing.
Yeah, it's like
It's got a little piano to it. It's pretty cool.
yeah, I was like, if you really listen to the song over and over, you sense like you can get some of like the bass note that is kind of changing it with like the rhythm of it. Yeah, I think there's like, and there might be some delays in there too because sometimes there's some like periods where it's not changing that maybe it should be, but yeah, I think like basically you can adjust this to sort of track. Basically, this is like subtracting input signals in a way that sort of helps. Anyways, but yeah. Basically, not perfect.
Wow. You did what you said you were going to do.
Yeah.
Oh, that's really cool. Yeah.
Thank you.
Yeah. I think that's a really interesting way to think about visualizing music too. It's kind of what Vinay was doing, going back to the very first thing. I was looking at the different brainwaves, filtering out for particular regions.
Yeah.
Because you can extract a lot of information that way.
Mhm.
That's something that you could also use to feed into a neural net sometimes.
Right.
To recognize particular
Yeah.
configurations. Really sophisticated. As a first attempt, that's really remarkable.
Right. Thank you.
That's really
It would be interesting to like see what kind of like real meaningful applications this could have for sure. Like adding that in there. Yeah.
Okay.
I have a question. This is really
Yeah.
fun, but
Oh,
like,
sorry, I didn't mean to step on people's questions.
No worries.
So like the thing you're mapping is the base key, or sorry,
yeah.
it's just a base. Like
Yeah,
every
it's-
time base is triggered.
It's sort of based on the lower frequencies in the music, basically. So I was just attempting, like it's not perfectly accurate, but it's like based on that filter, like trying to
So it's like a beat tracker.
kind of like that.
Yeah.
I guess like
That
in
that's
effect.
really
It's-
cool. That before I realized it's a beat tracker.
Yeah.
Yeah. What I think is great is it's not a very good beat track.
Yeah. Yeah, I think it's because it's sort of like not there's flexibility in what you can have it change to. So if you wanted to expand it to include more frequencies.
Cool.
This
That's fine.
All right. Karen, what do you got?
Okay, so I so basically, I pivoted my idea a little bit, from my original like customer support like data set, and I found like another like kind of cool like data set just regarding like red wine variants from Spain.
I like it already.
So I started by like trying to kind of like referencing the like JFK weather like patch that we were working on earlier. So like I kind of like just got to like extracting the numerical columns of like rating and price from the data set, but then like I got a little stuck because like I had a vision of like how I wanted to like sonify and visualize the data, but then like I like ran into some obstacles for this, like making it work. So I kind of just like made a presentation about like what I wanted to do. That's okay.
You're going to do well in the world.
Like-
This is basically my life. I never does what I wanted to do, so I just make stuff up.
Yeah, so this is basically, I just like made a presentation about like what I wanted to do and like kind of like, so this is just like some context, I guess, like on the data set. Just like fun fact, like Spanish per capita wine consumption is like 3 times the worldwide one, and then like the total Spanish wine production is 16% of the total, so which makes it like 3rd largest country behind like Italy and France. So the data set like I pulled has like 7,500 variants of like red wine from Spain, sort of like across like many time periods, and these are kind of like the attributes of that data set. So I guess like these are some like research questions that I kind of wanted to like explore like from the data set, and like from I guess like extracting the 2 columns of like price and like ratings. I was focusing more on like, are more highly rated wines like more expensive, like trying to see if like there is any way to like sonify and like visualize like that data from the data set. So like this is kind of like how I wanted to like approach the research question, sort of like analyzing by like the wine region in Spain, sort of like if like possible at all, like making like the music like string music, like if you're at like a vineyard, like sort of like playing in the background while you're trying out like different like things in Spain. So like I wanted to like play around with like the price for like amplitude, and then like in terms of like frequency, like making like the higher the like weighted rating, because like the ratings are like kind of like 4.2 to 4.9 in the data set, and like the number of ratings also varies, so like having that like kind of be like weighted by number and like varying the pitch from that. And in terms of like duration, like there's approximately I guess like 100 years of like data in the data set, so like if it's like around like 3 seconds per year, like kind of like a 5-minute long song if you go by like years. So like I thought that like the frequency of notes played could be like distributed evenly across the time period, so if there were like more wines like in a specific year, like it would like play a lot faster than like in years that are more spaced out. So like either you can play like the regions like one at a time, or kind of layer it over each other with like different like string instruments. So like that's kind of like what I wanted to do, like from a more like music on like this music side, and then like the visualization, like I thought like it could be cool sort of like having like this time-lapse experience like across while the music is playing in the background, sort of like going through the years, and then like from like I guess having like kind of like a heat map from like yellow to red, showing like the price and like the weighted ratings for each region, and then like sort of like the number of wines that are like in the data set per year, like just like having like an icon sort of appear while like the heat map is kind of like sliding in scale like in color, so like the visualization aspect. And then like I guess just like finally like what can you apply like with this data set besides just like playing in the background is like if you're able to like understand like what characteristics of like wine pricing quality like over time, like how that affects like how like wineries can like approach their like pricing strategies, but like to like serve their customers or kind of position themselves for like long-term success, but like also just like from like more of like a sonic and visualization of data perspective,
Yeah.
it could be like cool to see that too, but
Yeah, I think
I
so.
unfortunately wasn't struggled to like figure out how to do that exactly.
I mean, everything I think you got all the stuff in place, you know, kind of like Eliana, you're kind of really set to do it. I'd like to see what you wanted to. Because, yeah, first of all, I mean, as a tool, as even a marketing tool, you know, it's an interesting way to present stuff that people will find it kind of attractive, you know, so if people, oh, let's listen to this, they can actually learn stuff that they wouldn't learn if you just say, here's some graphs, you know, or something like that. And secondly, you don't know what you're going to get out. You know, you might find some pretty cool sounds. You know, it's funny. The 3 seconds per year reminded me of something that one of my former students did. A guy named Luc Dubois. He's the guy that wrote Jitter.
Oh, no way.
And he's teaching at NYU now. But he did this interesting project where he looked at what was the #1 song for the last 50 years according to the Billboard Hot 100 charts. And what he did was he took each song and made an average of all the notes that you would hear in it. So like a song would go or something like that, you know. And then he had each one be like 3 seconds per week or something like that. So like when you would hit like, oh gosh, the Bee Gees, Saturday Night Live, Saturday Night Fever, you know, it was like, you know, there'd be like a half a second because their songs were hits for so long, you know. Then you'd get a bunch of like weird ones when the hair metal bands came in, and then Michael Jackson, you'd hear like 45 seconds of, and that was like Billie Jean, you know. It's amazing. And then because it was all the average, as soon as rap started coming in, all of them had kind of like a weird pitch to them. As soon as rap came in, it was nothing but noise because it was drums and bass, you know. You know, it's amazing stuff. So I think those kinds of things could pop out of this exercise. I think it'd be really fun to try.
Yeah, definitely. I'm really excited to keep working on
Plus,
it.
I like Spanish wine. I like Portuguese wine a lot too. I love you. Yeah. Good job. Okay, so we've got one more kind of an honorary presentation. Hannah joined the class a little later.
Yeah, I'll be quick. I know time is valuable.
Actually, we're kind of right on time. This is pretty amazing. Yay.
So I share screen and share sound.
Yes. And if you're using MaxMSP, you'll have to,
Yeah.
Oh, yeah. This is pretty cool.
So provide some background. Barnard Computer Science Center had this very brief like screen art tech competition exhibition thing, and this is actually for that exhibition. And I actually talked to Nicholas, who provided a lot of help. It's just that after that, it goes into final weeks, and I just have to give it a pause, and then I'll visit it during the summer, and in a later presentation, I will talk about what else I still want to do with projects. I'll put some okay. So this is almost like what I present to Nicola, but here you are. So I'll just talk and I play. This is a heat map of New York City, which is the map is called the Heat Vulnerability Index, which is a combination of how much of the Earth's surface heat is, and also whether this region, this neighborhood has air conditioner, and also their income level, and also perhaps like an urban surface, how much of concrete area there is, and how much like green space there was. So you can see how Central Park is gray, and further up north it's also grayer, and closer to Harlem and also some part of Brooklyn it becomes much more darker, which means they're more vulnerable. I will open this patch to illustrate what my thought process were. So initially I wanted to use a CSV format data. But I search around and the only thing I can get is more like geologist style data, which is full of spatial dimension that's more like really hard to deal with for someone who does not have any knowledge in geology.
It's like GPS coordinates.
It's like what they use in Google Earth Pro. So they have spatial location, but because it's measuring of heat, so first the boundary is not very clear. You can see more like spectrum like heat, but also they have some kind of height dimension. So it's just hard to deal with. So I choose more like a urban studies type of data, and this is actually just an image that I use. I use this patch to turn it into, where is this? Why is it always frustrating? Turn it into a matrix of pixels. So part of it, I guess 70% of this is just I scraped from internet because obviously someone wanted to do this. So I repurposed for my use. I set the dimension and everything. So this will allow me to turn any kind of image into a pixels matrix, which I can also select on. So this window can select a region. But obviously I don't fully know how this window could be calculated. So when I adjust the side, there's a little bit of issue, but it kind of works. And then I'm basically just using the red, green, and blue data from this image. So any kind of heat map type of image could work. Because green is not very informational here, so I'm only using red and blue. So I do some simple calculation to make that the redder regions will sound more dissonant and higher frequency, and vice versa. And here, so this is changing both the pitch and the instrument that I choose. All from the MIDI, the MIDI list. So it's basically changing the instrument channel. And another channel is just a constant. I should definitely fix this. This is just a placeholder that I'm putting two very repetitive parts here. But I do look up the what's that called? Oh, the hidden Markov chain. And actually, if I open that one and I just set up the way I want to generate the number, because I can open two patch simultaneously, the sound would just be replaced by random melody. So that's work I checked. I just haven't incorporated into these projects. And then this is just setting up the screen. And this is not very anything. It's just a little quick test of I want to incorporate some kind of other sensory modality into it, so that when I click on a wider region, it will speak to Arduino and activate a fan. I tested it in home and I didn't get it to make it in the activation, but then I thought it's a bit silly because the purpose of this project is not to like feel the wind. It's more about, because sound versus visual is much more immersive medium. If I'm just presenting visual, it's still image to you. Yes, you can pinpoint which part it's more vulnerable. It doesn't have this more, I guess, immersive feeling of your being there. I guess if you take a walk to this region, you would definitely feel the heat. So that's basically it. Yeah. Oh, and I want to do something that can make it optimize in a way that I can set up some kind of trajectory, something a little hot, so that it walks along some regions.
So you
So
gotta
they-
meet the, that'd be cool.
And then so that will play over time, and it will. I hope it could. I'm not sure how to work on this, but I work toward it. I hope it could simulate more like physical walking speed, so that we have a much longer duration. Mimic.
I have an object to recommend you do that. It's called Drum. It's actually, it's called Drum, D-R-U-M-K.
Okay.
It's an XNSP object that does a random walk.
Okay.
I was thinking that you could do the path of the marathon or something like that, like going through all the boroughs, hitting a bunch of different places and like showing
Yeah.
like how the heat changes as the runners are actually moving through the course, essentially.
What's that called?
For the marathon?
Is it the patch or?
No, like that's like using that as the path, like trying to define that on the picture
Oh, I
using
get
the
it.
marathon route.
The only challenge is because remind you that this is using an image. And
Yeah.
so I only get the X and Y coordinate here. So it will be, I'll probably have to find a better data set that will actually allow me to plan out the route.
Yeah.
Otherwise will be, or I can do something more like the MLP training where I draw out the route manually, but it should be effective if I know which neighborhood it is. And I
Yeah.
draw out the route and then replay it.
Yeah, because it doesn't have to be super precise. You just have to like hit the neighborhood and that's it.
Yeah.
Yeah.
Yeah, exactly.
I was gonna say to Karen, Nicola suggested the drop off of this thing.
Yeah.
Very fitting.